Hello, welcome to Cooking with Attribute Rules, utilizing Esri's Data-Sous chef. This will be a culinary themed presentation that's a bit GIF heavy. I had heard about attribute rules, but I really struggled with how to apply these in my own organization. I was driving to work one day and I had a moment where it just came to me, almost fully formed. So I sat down and wrote everything out. I was really impressed with how easy everything was. A lot of times you see a cool presentation on some of the new technology, but they seem to gloss over the secret sauce. So today's presentation is going to reveal that secret sauce. This is an in-depth tutorial where we'll take a look at the entire process from soup to nuts. I have something like a minimalist style, so I probably won't read any of the slides. So what are attribute rules? Here's a quick taste. This is an expansion of the database rules that you're probably already familiar with, like domains and subtypes, introduced with ArcGIS Pro 2.1 back in 2018. For all intents and purposes, they are SQL triggers, but they'll only pop within the Esri infrastructure. So your mileage may vary if you're doing database level stuff. The different types are calculation, constraint, and validation. The gist is you write predefined logic and the database will execute it against your data set. This can occur instantaneously or ad hoc in batch mode. And obviously anything you make, you need to maintain. So depending on how many feature classes you want to participate, this could get pretty big. If this were on a menu, it would have an asterisk next to it saying something like, this isn't a gluten-free kitchen, or eating undercooked eggs is unsafe, but we'll do it anyway. Spicy food is spicy, and that kind of stuff. So if you write attribute rules against your database, it will no longer be able to be opened within ArcMap, which no one should be using anyway. And depending on the expression features you are using, it may require a higher ArcGIS Pro version than 2.1. We're on 2.9. Should be using 2.9. You can and should utilize these things with your feature services. You'll need to make sure that certain capabilities are enabled. And finally, as much as we, and by we, I mean me, love Python, all of this scripting for attribute rules is done within Arcade. So it'd be nice if we had options that wasn't that, but that's not how it is. Back in my day, I would gladly throw on some big headphones, turn up the EDM, and just crush out the data cleric type stuff. I mean, I think that I was just geeked to be doing computer work all day long. Data clerics wear cloth and can't wield edged weapons. I'm really reconsidering the culinary theme right now. Should have been Dungeons and Dragons. These days, my views on the data cleric thing are more nuanced, which is to say, you don't want your professional kitchen staff to be peeling potatoes. And I guess the whole analogy I built this presentation around is a bit inaccurate. The attribute rules are less sous chef and more kitchen porter, but no one knows what a kitchen porter is, so we'll stick with the sous chef thing. The whole point of this slide is just to tee up the next GIF. So here it is. It's a laugh line. Yeah, generally the validation rules will throw up errors for you to fix at a later time, just like topology errors. The constraint rules prevent those kinds of situations by only allowing germane values to be input in the first place. I think that the bar is a bit high for both of those kinds of things. Instead, we'll look at force multipliers, or rather removing the manual entry of redundant and derivative data. All important things we'd otherwise have to calculate at point of analysis or elsewhere. All of the previous slides lead to this one idea, and that is we don't have to do it ourselves anymore. In other words, the point of utilizing attribute rules is so we can spend more time eating cookies and less time baking them. Who doesn't love a bullet time cookie monster? I guess my real goal is that you won't be able to think about food again without thinking about attribute rules. And the only way to break that curse is to go ahead and implement them at your own work. Maybe the most integral part of cooking is literacy, and more than literacy, a familiarity with your subject matter. It's just like IKEA furniture. If you don't read the instructions first, you're going to have a bad time. This might be the last GIF, I think, for a while anyway. Megan Cope told me that metadata is a love letter to your future self, and understanding the structure of your data is the secret ingredient to making this work. On a side note, if you have data sets with fields that you don't know what they are, that's a problem. Finally, we're moving to the demo part of the presentation. But first, here's the thing. This is the feature class we're going to work with today. In case you don't know, this is the NCT 911 road center lines that we should all be duly familiar with. And then we have a hint there of how we're going to try and look at it. And then we'll see if we have any ideas of how it's going to fit together. We're not going to panic. It seems like a lot, I guess, but it really is fairly manageable. Although the expression builder has line numbers now, it is my least favorite way of writing arcade expressions. So I use an IDE from Microsoft called VS Code. It's great. If you wanted a recommendation, that would be it. Anyway, arcade is obviously not an open source language. So instead of being able to switch the language to arcade inside of your IDE like you would a Python, we'll use JavaScript because it is JavaScript-esque. And that reminds me, I need to start opening up these code snippets. And real quick, before we start, this is just a primer of sorts for what we'll be seeing a lot of. I like to avoid if statements, if I can, I mean when I can. If you're going to make a variable, you have to initialize it using the var statement. All right, now we can proceed. This is the demo. We're gonna do the thing. We're gonna do the demo thing. So here's the demo thing. And we'll open up these two. Oh no. Sorry, I'm really messing up. I was almost there. Okay, yeah, there we go. Okay, so as not to intimidate anyone, we'll start with the smallest rule. And we'll make the font size bigger. Okay, there we go. That's better. It's probably better for most everyone. Maybe one more time. Okay, so we're going to start with concatenation, which is a fancy way of saying let's add things together. You basically squish strings. And so I wrote this in a really silly way, and then I did a lot of research online. I found a way that I liked a lot better, that was a lot more elegant, so I shamelessly stole it. So what we're doing here is we're making an array, and for Python people, an array is not a list, it is an array, but it's like a list. And we're gonna make a function here that's basically going to take whatever thing that we feed it, and it's gonna add it to a list, real simple. So in arcade, nulls are always your enemy, and they will always wreck you. And so we spend a lot of our time in arcade expressions writing things to get rid of nulls. So we're going to start out and say, hey, if this feature that we're feeding you, the function, if it's not empty, right? If this returns false because there's something there, then we're going to insert you at a location inside of the array the value of the feature that we fed. So all of that is to say, it's a fancy way of adding things to a bucket. Right? We're just putting stuff into a bucket. So hey, we're going to add in our values for our street pre-direction, our street's name, and our street's post type. And then that's it, the end. Now we have this when statement, and the way that a when statement works is it's a set of conditional testing that will happen in sequence. So from top to bottom, it's going to try and look for stuff. And then if it doesn't find any of those things, at the very end of the when statement is the default value. So if it passes all of your conditional testing, and it's just going to do whatever is in the default, right? Easy enough. So what we're doing here is we're saying, hey, if the street name is empty, right? If is empty evaluates to true, then inside of the street full name field, we're going to write, yo, street has to have a name. And then we're also, the next test is we're going to find inside of our street name field if there's a double space. And if there's a double space, we're going to say, hey, your street name's got a double space, so fix it. And then finally, we're going to evaluate our field name, street name, against our street name field with a trim function. And a trim function gets rid of leading and trailing spaces. So if these are not exactly the same, right, then that means you've got a space somewhere. We don't know where, but we know that you can look for it, find it, and fix it. And then finally, if it passes all those values, then we're just going to concatenate those features in this array, and we're going to use a space to join them together. So it looks like a regular address that you would write. So what that looks like in practice is you've got a lot of silly streets with two-word names. And I don't know why anyone thought that was a good idea ever in the history of street addressing, but we've got Harvest Ridge Lane. And if we were to change this, and then it's gonna automatically pop here, yo, street's got a double space. Or if we had a space on the end, it's gonna say, hey, the street name has to begin or end with a space. Or if we didn't have a street name at all, it's gonna say your street must have a name. Now, if we do everything right, we just have a normal regular thing, it's going to automatically put in the street full name. So we're not typing out the same thing that we already typed out. We're just using the data to work for ourselves and to do things in a normal way and reduce some human input. So that's concatenation, fairly simple and straightforward. Now let's go back to some code. This is the math one, and we're doing two things here. That's not part of the math. That's just what we're doing. We're searching for the evenness or oddness of a street range. And then we're also trying to determine what is the low of a range and what's the high of a range, you know. And what's complicated by this is that the street has two sides, right? You've got a left and a right. So we're just trying to figure out those types of things for the left and right side. So the way that normally you do a function is that you write out all the functions first, and then you do the stuff inside of your script. So we're going to just look at the functions first, and then we'll roll through the rest of the script. So this function I called determine even and odd because it determines even and odd, and you should have verbose names for your functions and variables. So it's going to accept two parameters, your to column and your from column, and then it's going to run a series of conditional testing using our when function. So here, this is a logical and, two ampersands. It's saying, hey, if your to column is 0 and your from column is 0, then obviously your parity is going to be 0, right? We know that 2 zeros and the parity is 0. We don't need to type in, don't need to select a drop down of, oh, that thing was a 0. It's, of course it's a 0 because we just typed in a 0. And then here, this is a modulus, and a modulus is division that only returns the remainder instead of the quotient. So if your to number is divisible by 2, right? If it divides and doesn't return anything, it's divisible by 2. And if your from column also doesn't return anything when you divide it by 2, then it is obviously even. Okay, easy enough. Then the same here is we're going to say it now. If we return a 1, right? If you 3 divided by 2 is 1, remainder 1. So if we have a remainder of 1, then it's odd, right? It's going to be an odd number. Those are all the tests. So we know if both of them are not 0, if both of them are not even, and if both of them are not odd, then the only thing that could be left is that it's some sort of mixed range, which you shouldn't have in your data set anyway. But we all have, I don't know who we all have, but we definitely have some legacy areas that have mixed ranges. So that's a B for both. Then next we're going to do this HighLow function. And it's kind of interesting because when you're evaluating high and low and you're doing like the data cleansing stuff, you actually run the same tests for both if you're trying to figure out something's low and if you're trying to figure out something's high. The only difference is that you run a min or a max at the end. So that's what we have here in our parameters is we're going to feed the function, hey, are you looking for the min? Are you looking for the max? And then if so, we have this little placeholder variable. Then we're going to just assign that placeholder variable a new thing. And it's going to be the min of the left column versus the right column, or the max. And then I set this like this. This default value is never going to pop, but I wanted to be super explicit. This would work. I want to be super explicit about why that function is there. It probably could be better than set this correctly. Then we're going to do some more tests. So here we're just saying, hey, if your left and right column are 0, then return a 0. If both, right? If both of your columns are null, and our columns shouldn't be null because they don't allow null values, but I put this in here because lots of things have null values. So if both of these are null, we're going to return 0 because a null is effectively a 0, at least when we're talking about address ranging. Then the next test we have is if both fields are negative, right? If your left field is less than 0 or your right field is less than 0, return everyone's favorite error message inside of the range high or range low, whatever we're looking at. So you know, oh, there's a problem, there's an issue. Again, something you could probably do with a validation rule. And then here is if your left is null, then use your right column. And the reason that we know that we can do that is because we can start doing like logical assumptions of if it was both null, right? Then this one would have triggered first. But we know that if one is null, then both of them can't be null, which means that the right column is some number. So we can just return that number. And then the same for this is just if the right is null, return the left. And then again, if this is a logical or, there's 2 pipes. If either of them are negative, then return an error. And then if either field is 0, return the non-zero field. And so we don't know if the left is 0 or the right is 0, we just know one of them is 0. And we know it's not a negative number because there's a test that we just passed above that. So if you have a 0 and a non-negative number, then if you run the max between those 2 values, you'll return the higher of those 2 values, which is good, which is interesting. So we write these functions just so we can make variables that use these functions, right? So we're going to determine the evenness or oddness of our left values and our right values. And then we're going to determine the high or the low of our, so here's from left and from right. We're looking for the from. And then here's 2 left, 2 right. We're looking for the 2. So these are going to return your high or low values. Then we have one final test because of the way that I wrote this. It's theoretically possible if you had a null value in one column, you could have a negative value in another column. But this is just saying, hey, if the low is higher than the high, then that's a problem, right? Your low should be lower than the high. Then return, and then if it passes this is if this doesn't happen, then go ahead and just return the low. So this is just another test, making sure that we're not putting in stuff that doesn't make sense. Now, the final thing that I love here, and we'll look at it here in a second, this is new as of 2.6, and you can return a results dictionary to edit multiple columns at once, which is great. So here we're going to have a result, we're going to have our attributes, we're going to figure out the low, the high, and the parity for left and right, which is super awesome. You can also do geometry updates as well inside of your rules, but we're not doing that today. Okay, so parity stuff. Okay, so here back at Harvest Ridge, we're going to do our left from to 0 and our right from to 0. Scroll this down just a little bit. All right, our from and to are now 0, so our left parity is now 0. Or if we do a 5 and a 5, then our left parity is now odd. If we do a 5 and a 6, it's now both. Or if we do something silly, like have a negative number, and all of a sudden we're going to get these error markings inside of our ranges. So interesting stuff, kind of neat, prevents you from doing something silly. Right, so it's going to say, oh, that's an error because your low is lower than your high. You know, anyway, so that's kind of cool. I think that's neat. Now we will look at the geometry one. The geometry one is neat. It looks crazy because it's really long, but most of it is just commentary to myself from myself. This is all of the geometry stuff, right? So this is the sauce. And it's all stuff that you as a GIS person should know how to do. Feature set by name is just a cursor. Just a cursor. It's a set. And so we're saying, hey, from our data store, you know, from whatever, the enterprise geodatabase or your file geodatabase, find the thing named boundary exchange, and then grab these two fields and don't return any geometry. Because normally, back in the day, you'd call it like this, right? This might look familiar to some people. But what that is actually doing, it's doing this. It's saying, hey, give me every single field in this feature class and then return all the geometry, right? So depending on the number of columns you've got in your feature class, and then depending on the number of polygons or points or whatever in your feature class, it could get really big and really slow, and you wouldn't want to do it. So only ask for what you need and don't use the geometry unless you like really need the geometry, which normally you don't. So that's what we're doing here, is we're just creating two little cursors to grab things from later. And then here we're making a buffer using the buffer command on whatever feature it is that we're editing. We're going to make a 150-foot buffer. And then we are going to find out if anything, our boundaries touch that buffer. So we're going to do an intersect. Everyone should be able to do an intersect. So we're going to say, hey, from this cursor of features, see if any of them intersect our 150-foot buffer. And if they do, this is now a feature set. This is now a smaller cursor that has just the number of results from that intersect operation. And that's the geometry. That's it. It's super simple. We can all wrap our heads around it. And yeah. So what we're doing next is we're going to we're going to grab attributes from those other polygon boundaries to just fill out redundant data that we don't need to do, that we know theoretically already exists. And if we did some GIS operations, we could prove that they exist. And so with that feature class, it's gonna do the thing. So we're gonna say, hey, we use this to tell our user, hey, you need to go check something manually, but we'll ignore that for now. And then otherwise, we're just going to have these variables, and we're going to pre-populate the variable with whatever's already going on in that record, right? So if that record has data in it already, we're not overriding it. We're just saying, hey, whatever's there, we're going to keep, unless we have a reason not to keep it. So here, we're going to check. We're going to check two indicator fields to see if it has been edited or not. And I know that really we're checking, we're going to potentially edit 10 fields, but we don't need to check all 10. We just need to check 2, because if this one is empty, we can assume the other 3 are empty. And if this one is empty, we can assume these other 5 are empty. These other 5 are empty. So that's all it's saying. So if it's empty, then we're going to say, hey, that there's no data in there, so go ahead and check. Go ahead and check. Use your eyeballs and check it out. So now, if our intersected feature set, right, when we did the buffer versus the cursor, if that returns only one result, what that means generally is that you're inside of a thing. You're inside of a single thing, and your 150-foot buffer didn't get you anywhere. You're inside of a polygon. Now, the caveat to that is if you have gaps in your stuff, right? Or if you're a border entity like Prosper, and there's another 911 region that you don't have data for, and whatever. But for most everyone else, you can use this, and it's kind of cool. So we're saying, hey, if we only have one feature, then we're going to make a variable in scope to access the data that's inside of that feature. So we're going to say, hey, these feature variable names are now, using dot notation, the column name from the polygon. It's the feature that we've intersected. So using that person's column name, we can now assign its data. So the same way we do like a spatial join or copy attributes tool or whatever, boom, right here. Like, that's it. 0 overhead, you just got it. And so we do the same thing here. If there's only one result, then we know we're inside of a thing, and we can go ahead and overwrite it with this data that we know is correct. And then finally, we're just going to return this result dictionary. And so these values are either the data that was originally in the record, a string that says check this, because we don't know, if you receive more than one intersected result, if you see 2 or n or whatever, then that means like, oh, you're close to something and you should check it out with your eyeballs because you're a person and you can do that. So it's going to return either check the original value or the value that you gleaned from that other polygon, which is super. And we'll just show it because it's hard to talk about it and it's easier to show it. So here we are well within this polygon. There's actually 2 polygons. So each color is a different whatever things. They're all stacked. That's why they look weird. Okay, so we're looking at this, right? And we're like, let's see, we're doing ESNs. Okay, so we can try to set this to null, which is also super cool. And then nothing's happening. And that's because the data set knows for a fact that we're inside of an area, that it knows what the data is. So the data is automatically going to populate, and it's going to be great. But here we are at an intersection of 2 boundaries. So when we do our 150-foot buffer, it's going to grab, actually, let's not do that one. Let's do this one. It's going to grab more than one thing. And so when we look at it, right, we're going to say, hey, what's your ESN? It's like, oh, I know what the ESN is because I'm inside of that boundary 100%. But when it goes to the exchange polygon, it doesn't know. It says, hey, there's more than one thing here. So we automatically change all of our stuff to check. It's like, yo, use your human people eyes and do the thing, right? So we can say, this is Prosper on the left, and this is this is McKinney on the right. And the rules have like no, they're like, yeah, sure, whatever. We're just letting you know that when that's empty, you should check it. And when it's not empty, we're going to assume that whatever you type in there is correct, which is nice. If there are smarter people than me that know how to figure out the stuff of leftness and rightness, I'd be super interested to know. Anyway, and then the same over here. But instead of the exchanges, it's going to be the ESNs. So if we set that to null, all of a sudden it's going to say, hey, I don't know what county I'm in. I don't know what the ESN is. You gotta look and you gotta tell me. So that's the geometry rules, super cool. And now we can finish out the presentation. We'll just finish it out. Okay. So we covered concatenation, which is neat. We covered math stuff, which was neat. I'm gonna just keep saying the word neat over and over. We did geometry stuff, which is okay. That's the end. Metaphorically, I guess. That QR code has a copy of this presentation. All of the code we reviewed during the presentation, code drafts that show its evolution, and also document with links to a bunch of supplementary materials. And I share this because sharing is caring, and we should all share our code. And if you're hoarding your code, you're not helping out your fellow community members, and we grow together, rising tide and all that stuff. So I love this. I love this stuff. We have time for questions. I would love to do questions. Questions are cool. And we can do that.
Yeah, go ahead. Does anybody have any questions?
And then also, I guess, well, if people are deciding if they want to do questions or not, attribute rules are real easy to access. You just go to your data tab and then click on attribute rules. And then here's the thing. And you've got multiples, and if you want to turn on line numbers, even if you're not going to use attribute rules, right? If you ever have to use the expression builder, you can just right click on it, say show line numbers, and now you've got these great little line numbers that you can use. Yeah, anyway, that's the thing.
Well, I think everybody's in a food coma.
Cool. All right.
All right. Thanks, Jordan.
Yep, no problem.